Greetings and welcome, friends. Mr. Waddy here. I'm taking a look at page 194. We've been talking about rotations. I'm going to go over a handful of these homework problems for you as best I can. Let's see how well I do. So it says trace the polygon and point P, then draw a rotation of the polygon around point P using the number of degrees. So we were given a 30-degree rotation, which, just so you're aware, a positive rotation is counterclockwise, so that's the direction that I'm expecting to rotate this. So once I have it all traced, I would have to take out a protractor, and let's see how well I can do this using my drawing tool. And I would then, I got to line it up. Let's see. So I'm gonna line this up so that the base, the center, is lined up at my point of rotation, and that the line passes through, say, point A here, like so. So now that I've got that set up, I would be interested in marking where a 30-degree angle is. Now my protractor, I'm starting from 180, so 10 degrees, 20 degrees, 30 degrees. Oh, that's what I got to do. I got to deselect my selection tool. Classic. All right, so 10, 20, 30. Here is a 30-degree angle. I can now hide my protractor, put that away. And what I'm going to do is to imagine the line that passes from P through my 30-degree angle. So I'm thinking of something like this. So something like that, right? And when I'm thinking about this, I know that this distance, I guess I can draw that. Let's do it. Let's do it. Let's do this for real, for at least for point A, and then I'll speed along for the others. Right? I know that I'm expecting this distance to be congruent to where A prime is going to land. All right, so I've just measured a 30-degree angle, and now I've just got to figure out where the intersection is going to be. So I would either use a compass or something to that effect, and you could set the width of your compass, the radius of the compass, to be from P to A, and swipe it across. Theoretically, you could have measured this segment and then measured out that far there, but these are going to be congruent, and my new point is going to be point A prime, right there. Okay, so that's just for one of the points. Now I'd have to do this for the remaining points. So let me just, let's see, maybe I can. So I would take out my protractor. I would line it up. Let's see, am I working in the right layer? No, I'm keep forgetting which layer I'm working in. Lots of things going on here. So I would rotate this so that it's going to line up. Let's do point C. So the center is going to be there. It looks like if I was to continue this, that would intersect point C to that effect. And then I would measure out 30 degrees. Let's see, this and this. So 30 degrees, 10, 20, 30. So here is kind of my tick mark on my protractor. I can get rid of my protractor. And now I would take out my ruler tool and draw that new angle. So this angle right here, this line should form a 30-degree angle with the line that would have been PC. And let's see, so I'll just draw it out like that. And let's actually, I'll draw this one as well. I suppose if I drew this straight edge the first time, that would have been helpful as well. So here's my 30-degree angle, but now I need to mark somewhere on this blue line the same distance as PC. So I would take out my compass, I would set the radius of it to line up with C as such, and if I draw across, let's see, I'll use a different color here. I would draw across and I would end up getting a congruent segment, right? So this segment is going to be congruent to that segment there, and I have found the location of C prime, like so. All right, let's see. I think I'm on a roll. I'm figuring out my tool set here. Let's just do it for B as well. So this time I'm going to use green. Let me set my ruler tool first. So line it up at P, figure out where B to C is, like so, all right. And I would open up my compass, or sorry, my protractor. I'm going to work in the protractor layer. Oh, let's see, hopefully I swapped it back. It'd be funny if I end up rotating a bunch more than I meant to here. We'll see. Ah, phew, wonderful. And so I would line this up such that P is selected and the angle is along that green line. All right, so line them up, something like that. Go back to this layer. So now I'm going to count out 30 degrees. So let's see. 5, 10, 30, right? 150 is 30 degrees less than 180 if you think about it that way. So somewhere about there. I think you guys agree. Remove my protractor. Let's draw the line. Let's see, line it up with my tick mark from my protractor. So now from green line to green line, that is a 30-degree angle, okay? But now I've got to set my compass for BP's distance and arc it over for that remaining value. So let's see, so set my compass distance for BP. Let's see, what's a good color here? Maybe I'll do this dark blue. I'll swipe that across like so. There's my intersection, and I would label that point right there as B prime. Now let's connect our dots and draw our new triangle. And since rotations are a rigid motion, rigid transformation, the new triangle is going to be congruent to the original white triangle here, and all of its corresponding angles, all of its corresponding sides will also be congruent, okay? So lots of work, lots of measurement, using a lot of different tools to make that happen, kind of tricky. All right, let's see, here we go. Graph the polygon and its image after a rotation of a given number of degrees about the origin. Okay, so 180-degree rotation that we're doing. What we're going to end up doing here is it's about the point of the origin. And I could do a similar thing that I just did where I could, do, my line tool and set it up at the origin. 180 degrees, that one shouldn't be too bad. So let's see, I can't make it short enough to go through E, right? But I would think of this, and then I would go out. So that's over 1, up 2. I would expect going out right here to land for point E prime, something like that. E prime. 180-degree rotation, whether clockwise or counterclockwise, will land at the same spot, so it doesn't matter in this case. But I get E prime there. It's going to be equidistant from the point of rotation, like so. However, we had a little property yesterday for a 180-degree rotation about the origin. We had a translation rule that any point A comma B is going to then become the opposite of A and the opposite of B. Okay, so let's see. So what were the coordinates of point E originally? Well, that was at -1, 2, -1, comma 2. So is this in fact at 1, comma -2? And behold, it is. It is. So if I only knew the coordinates of these points and wanted to figure out where the image would be, I could just use this property and not even have to visually construct it. All right, so let's try that for point D. So point D appears to be at -3, -1. So that means D prime should be at +3, +1. +3, +1. So there's D prime right there, right? E prime, D prime. And notice that it is in fact 180-degree rotation about the origin, and they are equidistant from themselves. Let's do the last one for f. So f is at 4, -2. So I would expect at -4, +2 is where f prime would land. And I've gotten to like drawing my little straight edge triangle here. So let's see. So here's f prime. Let's see, where's my other point? Here's d prime. So let's draw the image of f prime, d prime, e prime. I guess you probably wouldn't have labeled it in that order, but it's all the same triangle. And the purple triangle is congruent to the blue triangle because rotations are a rigid transformation. So being familiar with these little shortcuts is kind of nice. You should make sure you know how to do that. Okay, here we got composition of transformations. So we're going to have multiple moves taking place. So let's plot these points. So graph xy with endpoints. I'll graph this in green. -3, 1. So -3, 1. Here is x, and y is at 4, -5. So over 4 and down 1, 2, 3, 4, 5 is y. So there's y. Ugh, that was an ugly y. And x as such. I'll tell you what, we'll connect our dots here. We'll connect the dots, because it is a segment. And as long as I'm willing to take the time, this looks so much better when I do it nice. So there's x, y. So the first translation is that it's vertically being shifted up by 2. So here, so my new x up 2, x prime, is right there. Y prime would be shifted up by 2. If I thought about that vector in component form, that would have been 0, 2, right? As far as the translation, let's keep orange. We'll connect our dots. Ooh, let's see if can I line it up. Oh man, if that doesn't convince you that's a rigid transformation, I don't know what will. So there we go. And now we're going to take this orange outcome, right, this image, and rotate that 90 degrees about the origin. So 90 degrees about the origin. We're going to be able to find our new points. Let's see, what's a good color? Purple. Yeah, purple is a cool color. So let's see. So this point is at -3, 3, and my new location, 90-degree rotation about the origin, should land right there. Let's see if we can figure out what would the rule have been for a 90-degree rotation about the origin for x prime prime. So -3, 3 became -3, -3. So it looks like for this, any AB should become, let's see, A comma -B. That worked in this case. Or actually, oh, I've got to be careful. Ooh, right, because both of those happen to be the same coordinates. It might have also switched them around. So let's see, maybe we don't know that yet. This next one will prove it for us. So let's see, yeah, it's going to require a swap around as well. So for y prime to go to y double prime, a 90-degree rotation about the origin. So 90 degrees, it's going to be something like that, and equidistant. So notice to get to this point, I was down 3 over 4. So I think I'm going to have to go over 3 and up 4, over 3, up 4. Does that look like a 90-degree rotation for that? Looks like. So this is at the point 3, +4. This was at the point, I guess I'll switch it back to orange there. This was at the point 4, -3. So as far as my rule, let's see if we can derive it. It looks like A and B switch. So this is going to be B and then A, is right. 4, -3, 3, +4. And then the second position opposited. Okay, so B, -A. B, -A. And let's draw our line. And beep. And so the composition of, went too far, of those transformations, this is the end result, x prime, or sorry, x double prime, y double prime, like so. Let's see, does our rule end up applying for the x prime and x double prime? So this was 3 or -3, 3. If I swap them, so let's see, -3, 3, and if I swap them, Boy. Let's see. 4, -3. Oh, I wrote it wrong. Yeah, the -3 became positive. It was the first thing that became positive. Oh, silly Mr. Waddy. Well, it's a good thing we tested that, wasn't it? We come up with a conjecture, we test it. I've just made a counterexample with my first case. So let's see. So did that work for x prime at -3, 3? Does that transformation work of a rotation? Here's my transformation rule. That would have become, so the -3 flips over here, so that's -3, and this +3 now is first, and we opposite it. Now that works. We are good, good, good. All right, now for some kind of conversational discussion piece here. Making an argument. Your friend claims that rotating a figure by 180 degrees is the same as reflecting a figure in the y-axis and then reflecting it in the x-axis. Let's pick a point. So let's see. Let's do like 2, 5. All right. So there's 2, 5. I'll call this point A. All right. So let's do the first situation. So rotated 180 degrees. That's going to be at -2 and -5. All right. Here I'll swap my colors. So -2 and -5. That would be my A prime, doing a 180 degree rotation like so. Okay. Now let's see if the same thing would happen if we reflected. Let's see, reflection over the y-axis first, they claimed. All right. So I'm going to reflect over the y-axis. So so equidistant is 2 and 2 and perpendicular from. So yeah, so it would be at this point here. So I guess I'll have to call that double prime in a minute. So A prime is at -2, 5. And then if I reflect over the x-axis, I think you guys can see and agree that A double prime would in fact land at -2, -5. So it does appear to work out in this instance. And as far as more meaningful evidence, here's the book's argument, which I think is interesting. They were doing it from kind of the rules sort of approach. They said the following. Yes, your friend is right, because a reflection in the y-axis then x-axis yields xy becomes -x, y, and then that becomes -x, -y, or the opposite of x, opposite of y. And a rotation of 180 degrees about the origin yield. So we can see that those do in fact end up being the same thing. All right, last question. Is it possible for a figure to have 180 degree rotational symmetry, but not 90 degree rotational symmetry? What do you guys think? Yeah? The answer is yes. Yes, it is possible. Case is a rectangle that is not square. All right, let's draw the saddest rectangle. Ooh, there we go. Here's my sad rectangle. If I rotate 180 degrees, so about the center, it would map back onto itself. However, if I was to rotate 90 degrees and land there, the rectangle would not be matching up. So it would have landed like that. It would not have 90 degree rotation. So there we go. Thank you for watching, internet friends, and have a great day.